In this example, we're going to take a look at a non-standard basis of R3. We're going to allow B prime to be the basis, 3 halves, 4, 1, 3 quarters, 5 halves, 0, and 1, 1 half, 2. Now, according to the standard basis, if we have the vector x, which is 3, negative 1, 8, I'm interested in finding a representation of this vector relative to this basis. So first thing I'm going to do is label these three vectors up here as being the vector v1, being the vector v2, and being the vector v3. So our goal is to try to figure out coordinates c1, c2, and c3 such that the following linear combination is going to be true. That should be a v3. So c1v1 plus c2v2 plus c3v3 is going to wind up being equal to the vector x. That is to say, c1 times 3 halves, 4, 1, plus c2 times 3 quarters, 5 halves, 0, plus c3 times 1, 1 half, 2, is equal to the vector 3, negative 1 half, 8. Now with those things in mind, we can start by setting up a 3 by 4 augmented matrix using our three vectors, v1, v2, v3, as columns of the matrix. So for the first vector, 3 halves, 4, 1, gets loaded into the first column. Our second vector, 3 quarters, 5 halves, and 0 gets loaded into the second column. And the third vector, 1, 1 half, 2, gets loaded into the third column. We'll be augmenting that with our target vector x. Excuse me. Taking this down to reduced row echelon form will inform us of the value of c1, the value of c2, and the value of c3. Now in order to do so, we won't be doing so by hand, rather we will be using the graphing calculator for this purpose. So, entering the matrix menu, we will edit. We'll need a 3 by 4 matrix. First row will be 3 over 2, 3 over 4, 1, and 3. Second row, 4, 5 over 2, 1 over 2, and negative 1 over 2. Third row will be 1, 0, 2, and 8. Then I'm going to recopy down the matrix A just to make sure that everything got inputted correctly. You'll notice some decimals in here. If we press math followed by enter, we can see this in its fractional form. First row is looking good, second row looks good, third row looks good. All right, back into the matrix menu. We'll hit up RREF for reduced row echelon form, select our matrix A, and hit enter. Now it looks like the numbers that we had turned out pretty nicely. If we did come up with decimals though, we would change those into fractions. So our reduced row echelon form, we see the identity matrix, which is expected because the initial vectors formed a basis of R3. That leads us to a unique representation of any vector in R3. So we can interpret this in the following fashions. The coordinate matrix of x relative to the basis B prime is going to be the matrix 2, negative 4, 3. Now we can interpret this to mean that if we were to take 2 times the vector 3 halves, 4, 1, minus 4 times the vector 3 quarters, 5 halves, 0, plus 3 times the vector 1, 1 half, 2, we would wind up with our target vector of 3, negative 1 half, and 8. Great little exercise for you. Just go ahead and verify that our answer is in fact correct.